These notes are around functions. The essential question for today is, how do I identify key features of a function? So they will cover what is a function, how do you tell, and what are the key features that I'm supposed to be finding. So the first thing that we talk about is a function. What is a function? So the definition is a relation, which is a table, a graph, a set of ordered pairs, where each x value has only one y value. So we watched a video last week when we did module, I think 3.1, to kind of talk to us about those things. Here are some really good examples, sort of like a table. In this function, when the input is 1, the output is 3. When the input is 2, the output is 4. When the input is 3, the output is 5. When the input is 4, the output is 6. So each one of these x values goes to a different y value. So that would make it, yes, a function, right? That's why this is the function side. Another example of a function is 0 goes to 0, 1 goes to 1, 2 goes to 4, negative 2 goes to 4. So these x values all have one output, which is y, or which is a different y. Even though 4 repeats, that's okay, because this x value 2 goes to 4, and then negative 2 is a different x value, and it goes to 4. Sometimes I think about this as a soda machine. When you put in your money, you should only get one soda out, right? You put in your however much they cost now, and then one thing comes out of the vending machine. But if you put in one input and you got two cans of soda out, although it's a benefit to you, the machine is broken, right? So if you put in your input and you get one thing that comes out of the machine, then it is a function. It works. Not a function, a broken machine would be if I put in my money and a 3 and a negative 3 came out. 2 cans of soda came out of the machine. These would be examples that are not a function. So one way that the video explained it is that x's can't repeat, but y's can. So that might be something to remember. Here's an example set up more like a table. So negative 1 goes to 5. So none of the x's repeat. These only happen once. So this is a function. On this table, 4 happens twice, and this one, a 7 comes out, and this one, a 14 comes out. So this is an example of like putting money in a vending machine. If I put in a 4, 2 different sodas come out, a 7 and a 14. So that is not a function. Even though you benefit, the machine is broken. It is not a function. So that's how you tell in a table. And your reason to say that it is a function is that each input has only one output. And to say it's not a function, you would say, when I input 4, there are 2 different outputs. That's why it's not a function. If you're looking at a graph, we do something called a vertical line test, which means anywhere in my graph, if I make a vertical line, I should only touch one point. If I touch 2 or more points, then it is not a function. So looking at this one, this is a discrete function. I'm going to draw a vertical line at every point. That one only touches 1 point. Only touches 1 point, only touches 1, only touches 1. So this graph is a function because it passes the vertical line test. That would be your explanation on the test. Looking at this graph, if I drew vertical lines, I'm only touching 1 point because nowhere on the graph do the points stack on top of each other. So this one is also a function. This is another discrete function. Only touched 1 point. Only touched 1, only touched 1, only touched 1, only touched 1, but here I touched 2. So this one is not a function, and it's not a function because at the input of 4, I have 2 outputs. I have a 4 and a negative 1. So that's not a function. And you could say that's not a function because it does not pass the vertical line test. And then here is a continuous example where almost anywhere I draw a line, I'm going to touch 2 points because it reflects, right? And all of these are stacked on top of each other. And anytime in a graph where points are stacked on top of each other, it is not a function. So it is not a function if points are stacked. On top of each other. And then the assignment in the module is a really good practice example of sorting. It's got tables, it's got graphs, it's got ordered pairs, and your job is to decide if the function, if that example is a function or if it's not a function. And I feel like that will really help. So that first page is all examples of things that are a function and things that aren't a function. The second page of notes is over these key features. So the first key feature we've been kind of talking about since Module 2 is domain. And domain is x values, and x's go from left to right, so we're really measuring the width of a graph. How wide does it go? So when we write it, we're going to be using interval notation, and we're really just talking about find what's the leftmost number, what's the rightmost number, and then it's the span of numbers in between those 2 points. So we're going to look at this graph and take your highlighter or pencil and find the leftmost point. And so this is the leftmost point, right? And this is the rightmost point, and that is the width of my graph. So if I'm writing the domain for this graph, I'm going to find the value of this number. So 0, -1, -2.5. So my lowest value, my leftmost value is -2.5. This is for domain. And my highest value is right here, and that's 1, 2, 3, 4, 5. So what I just wrote down is that all the x values in this graph go from -2.5, which is the leftmost point, all the way until +5. That's the rightmost point. And then we have to talk about whether we use interval notation is a shorter way of finding that. So we just did it. We listed our -2.5 and 5. But this looks like an ordered pair for a single point on the graph, and it doesn't represent a single point. It represents a span of values. So we use these brackets and parentheses to help us, A, know that it's the domain, and B, tell us about these points. So if you notice, the point 2.5 is a closed circle. So that means that 2.5 is a number that is included in this function, in this table, in this graph. And so if that point is closed and included, then we use a bracket. So brackets are for a closed circle. Anytime there's a closed circle, you use a bracket. Anytime there's an open circle, you're going to use a parenthesis. So this point on the right side is an open circle. And basically what an open circle means is that you can go all the way up to 5. You can go 1 counts, 2 counts, 3 counts, 4 counts, but 4.5 counts, 4.6 counts, 4.7 counts, 4.9, 4.99, but not 5. So you can get really close to 5, but not actually be 5. So that's 5 is more of a boundary and not a number that counts in the table. So the domain of this function in interval notation is bracket, because it was a closed circle, -2.5 all the way to +5, parenthesis, meaning we can go up to 5 but not actually be 5. That, my friends, is domain. We just measured the width of our graph. And now we need to talk range, which is the height of our graph. So range is y values, height, which is going, remember y values are the vertical axis, so it's going up and down. So we want to find the lowest point on the y-axis and the highest, and we're going to list them in a similar way. So for the range, We'll do that below. So let's measure some height. Find the very lowest point in my graph. So this point is the bottom, the lowest. So I'm drawing up this line here to help me find the y value that it matches with, right? And that's the point -1.5. So -1.5 is the lowest value on my graph. And then the highest value is this point here. And that lines up with +1.5. So what I'm writing here when I write range is I'm saying the height of this graph starts at 1.5, that's my low, or -1.5, and it goes all the way up to +1.5. That's the only y values I can have, but since this is a continuous function, it's all of the y values that span between -1.5 and +1.5. And now we just need to tell the reader of our notation if it includes those numbers or if it's a boundary of those numbers. So this one is a closed circle, so that means that -1.5 is a bracket. It is included. It could be a number in my table. But +1.5 is an open circle, which means I can go all the way up to it, 1.4, 1.42, 1.499999, but not actually 1.5. So that is my domain and my range. And then just a reminder that in a graph, a bracket means a closed dot, parenthesis means an open dot. Okay. Next, we're talking about x and y intercepts. So the y-intercept is where any point on the function crosses the y-axis. So remember our y-axis is the vertical axis, is this. So you can see on this graph that one point touches the y-axis, and that is the point 2. So my y-intercept is the point 0, 2. And the y-intercept is always written as an ordered pair. It's the value of y when x is 0, because it's on that axis, right? And the x-intercept is kind of the opposite of that. The x-intercept is where the line crosses the x-axis. So remember, this is the x-axis. And I have one point here where the x crosses, and that is the point -2. So when I write the x-intercept, that's when x is the number, -2, but y is 0. So notice in the y-intercept, x is 0 and y is the value, is a number. And in the x-intercept, x is the value and y is 0. And in tables, it's similar to that. Let's see. Let's make a table of this one. So the x-intercept, or the y-intercept, is going to be this point, 0, 2. It's where we're looking where x is 0, what is the value of y? And then the x-intercept is where y is 0 and x has a value. So those are the x and y intercepts. The maximum is exactly what you'd think. It's the highest point on a graph, and it's written as an ordered pair. And the minimum is the lowest point on a graph, and it's also written as an ordered pair. So you just find the high point and write the value, and there might be two points that are equally high, so you can list them both. And then the increasing and decreasing intervals, it's the span, and we're talking about x values here, but it's the span of x values where it's like finding the domain of the chunk of the graph that's increasing and the domain of the chunk of the graph that's decreasing. We still use brackets for closed circles, parentheses for open, and sometimes it takes a break. So I think if we do this example below, that will help make sense. So So I'm going to say that this is a closed circle and that this is an open circle, just to give us some practice. So our domain, again, is the width of our graph. So I need to find the leftmost value and the rightmost value. So it's like I'm cropping my graph, and I'm going to say, well, the leftmost value is a closed circle, so I'm going to need a bracket. And the rightmost value is an open circle, so I'm going to use a parenthesis. And this number is -2.5, -2.5. And this number is +3.5. So I'm just saying leftmost, rightmost, and then I did a bracket because it was a closed dot and a parenthesis because it was an open dot. Range, let me delete that. Oops, still an open circle. Range is the height of my graph. So I'm going to find the lowest point and the highest point. So the lowest point of my graph is a closed bracket, a closed circle, so I use a bracket. The highest point is an open circle, so I'm going to use a parenthesis. The lowest point is -5. The highest point is +5. So the span of y values, the height of my graph, goes from -5 to +5. And then for this next section on the test, I highly recommend that you highlight your graph, just so I can see if you write the notation wrong, but you can find those points. I can give you credit for that. Where does this graph decrease? Where does it go down? So this graph goes down from here all the way to here. That's a decreasing section. And it increases from here to here and from here to here, right? So here's a trick that we are teaching you. Since this green section right here is a closed circle, we're going to say bracket, because we know closed circles are bracket, and it's going to increase from that bracket all the way up to this little bump. And I'm going to put a parenthesis here because this point at the top, it stops increasing and starts decreasing, so it's sort of an in-between move. And so it's no longer included as an increasing number, but it's a change number. So those are always use parentheses. So bracket, increasing, and then it switches directions. So I'm going to use parentheses for that. And then it decreases, and then it's going to switch directions again. So I'm ending the decrease and I'm starting the increase. And then it increases again, and then parentheses because it's an open circle. So there was one chunk of decreasing, and notice in my drawing that I drew a parenthesis here and a parenthesis here. So I'm going to bring those over here. And it decreased from -1 to 2. But there were two sections of increase. So this first one was a bracket because it was a closed dot. Parenthesis because we were switching direction, and then this was a parenthesis. Oh, then it stopped, right? It increased from -2.5 to -1. This is the first chunk of increase, and then it took a break, and we use a symbol that looks like a U. It's a union. It means take a break from increasing because we were decreasing during that next chunk. And then it increased again from 2 to 3.5. So I'm going to say parenthesis, because that's what I used here to show change in direction. 2 to 3.5, parenthesis, because it was an open circle. So that is how, so this is like the domain of when it decreased, and this is the domain in chunks of when it increased. So if it takes a break, you use this U symbol. So the x-intercept is anywhere it crosses the x-axis. So I'm going to look along the x-axis and say, oh, wow, this one has 3 x-intercepts. And I'm going to list all 3 of them. -2, 0, 0, 0, and 3, 0. Those are all where it crosses the x-axis. It only crosses the y-axis once. at the point 0, 0, right here. And the minimum, oh, let's do the maximum, I guess. The maximum is the highest point, so that's this point right here. And that is the point 3.5, 5. And the minimum is the lowest point, and that is the point -2.5, -5. And that, my friends, is finding keeping